Okay, we're on chapter 5 now, doing equivalent ratios. So go ahead, take a second, read it, underline with a pencil what you think is the most important, and then come back and highlight with us. Remember, you are looking at the how-to. How do we write equivalent ratios? How do we find equivalent ratios and stuff like that? That's what you're looking for when you read math notes. Perfect. Okay, so this is what I highlighted. The main part right here is what we're looking for. But the other stuff is important too, right? So how a ratio can be written in words, right? So they have the example here from 15 girls to 28 students. We have 15 girls for every 28 students, and then 15 girls to 28 students right there as well, right? The whole reason why we want equivalent ratios is because it gives us a bigger scale, right? You can find out for any number. So if I were to take this example, right, for every 28 students, I would have 15 girls. Say if we wanted to find our campus, which is 1,400 students, I could totally find out how many girls there would be, right, using these ratios. That's why it's important, okay? So we're using giant ones. This is the biggest thing. And the way we use giant ones, if you multiply anything times 1, it gives you that same number. So basically what we're doing is unsimplifying things, right? So equivalent ratios. Right? So first, what you want to do is write it as a fraction. Right? And the second step you want to do is to multiply by a giant 1, right? And what that means is 20 over 20, that equals 1, right? 100 over 100, that equals 1. A billion over a billion, that equals 1. And then your ratio won't change. Okay, pause it if you need to take notes still, if you're a little bit slower than I am, but I don't want to take this video too long. So my example, say I had 2/3, right? And you can use, there's an infinite number of giant ones, but for this one, I'm going to do times 1 over 1, right? 2 times 1, so multiplying straight across. 2 times 1 is 2. 3 times 1 is 3, and it gives you 2/3. Same ratio, right? If I take the same one, 2/3, and I multiplied it by, let's do a different one. Oops. 2 over 2, right? Still 2 divided by 2 is 1. This will give you 4/6. Now, it gives me a different fraction, but it's the same value, right? 2/3 times, if I did 3 over 3, 2 times 3 going straight across, 2 times 3 is 6, 3 times 3 is 9. If I took 2/3 and I multiplied it by 10 over 10, right? 2 times 10 going straight across, 2 times 10 is 20, 3 times 10 is 30, and it gives me a different fraction that I can use, but remember, all of these have the same value, right? And look, I just multiplied by 1 every single time. 2 divided by 2 is 1, 3 divided by 3 is 1, 10 divided by 10 is 1, and it gives me the same thing. Okay, so complete these practice problems, and then you'll be done with this.